Oh, well, wait, before that, did I give you the 8.5?
Yes.
Okay, all right, thank you. Thank you, Ali. All right, so, yes, we're gonna work now on what we call the polar complex numbers. There's one rule in here. This is the MOV rule for getting the product and quotient of complex numbers. But later, we're gonna do that one, all right? But for now, the rectangular form from our pre-calculus algebra is A plus BI, where A is the real number counterpart, and the B is its imaginary number coordinate as well. So for example in here, if this is our complex plane, where the horizontal axis is our real number plane, and the vertical axis in here is our imaginary axis plane, or our what we call the I plane, right? Once again, I is equal to how much? Square root of -1, okay? With that being said, if that, for example, is our point A plus BI, right? Where that is your A, that's the real number. And B in here is negative, which is the I, or the imaginary counterpart of that one. So as we may notice, it's in quadrant 4. However, since we already know how to convert from polar to rectangular and vice versa, so which means this A plus BI now can be written as what? R cis theta. And what is R cis theta? That basically means what? R cosine theta plus I sine theta, right? So when you say R cis theta, that means R, C, that means cosine theta, plus I, S in here stands for sine theta, right? So the S in here, the C in here corresponds to X, and the S in here corresponds to the imaginary, right? So the C, real, and the S is the imaginary counterpart. Anyway, let's see in here. How do we do this? Okay, let's see. We have in here the following numbers. Let's see first, number, what's this? Number 8. How do we do that number 8 in here? Let's read the question first. Eunice, go ahead please.
-3 minus 3i.
Okay, what do we do? Find the what?
Find the absolute value of the given complex number.
Thank you. All right. So let's do that one, right? So how do we get the absolute value of, what is that again? -3 minus 3i. So this is our z, right? That is our complex number. Again in here, the -3 is the real number, and -3i is the imaginary number. First of all, what quadrant is this? Anyone? What quadrant is this one, guys? Third quadrant. Very good, right? So if you can draw that one, we can see that one as -3 as the real, and -3 as well as the imaginary, right? So with that being said, bless you, then that will be in here. -3 minus 3i. Okay. Now the question is, what is the absolute value of that? So to get the absolute value of this is what we're gonna do. The absolute value of z is equal to, we're gonna square the a. Similarly, we're gonna square the b as well. Okay. And then, square. And then get the what? Square root of them, right? So the absolute value is basically a, the real counterpart, b, just the coefficient, all right, without the I. The coefficient, -3, square it, you're gonna get the absolute value. So what is that? What is this one on your end? In simplified radical form. So this can be written as what? 2 of what? 3 squareds each, right? Z. Okay. To simplify this radical, what do we do with this perfect square? Bring it out of the radical. Okay. So we can remove this one, bring this out of the radical, and have that 2 inside, remain inside the square. So what's our final answer? 3 square root of 2. That is your absolute value of this. Questions? And honestly, that absolute value is actually equal to your modulus as well. Okay, so once again, that is also called a term called modulus. Or the distance, as you may notice in here, that's actually the distance or how far that point is from where? From the origin, from 0, 0. Question? So modulus, distance, absolute value, they're all the same. Hint, well, distance is basically always positive anyway, so you would notice that r in here will always be, absolute value positive. Okay? Next one. Let us consider now, what is this in here? Number 12, 13, and 14. What do we do with that? And let's choose a number as well, okay? Paula, let's choose a number and what do we do? 12, 13, 14.
14.
14, okay. What is that?
Negative 1/2 minus 1/2 I.
Okay, negative 1/2 minus 1/2 I. What do we do with this? What did it say?
Convert the complex. Oh no. Write the complex number in polar form.
Okay, so we need to write this in polar form. So how do we do that? There's we need a nice black pen. Yes. Well, blue will be well. How to convert to polar form, okay? Ready, guys? Okay, step number 1. Get its R, what we call the modulus. So in most textbooks, the term for that is called the modulus, right? How far it is from the origin, right? That's the modulus, okay? And now what's the formula for the modulus? That is basically what? A squared plus B squared. Square root of that, okay? So what's that gonna be? Okay, so that's your A and B in there. That's your A, and that's your B. So we use that formula, okay? So that's it. Negative 1/2 squared plus another negative 1/2 squared. Okay. Common mistake in here is the order of operations, right? So just be careful with that. Also, common mistake is the negatives. Consider the negatives as well. Okay. So what's this gonna be? Well, negative squared still gonna be positive, and the same in here, right? Now, there are 2 of them, so I'm just going to put in here the following. 2 times what? 1/2 squared. Okay. What's next? What do we do next? Well, we need to simplify it further, right? Whatever is a perfect square factor, bring it out of the radical, okay? So review your simplifying radical forms as well, okay? So in short, you see this 1/2? Remove the square and bring it out. So with that being said, what's the modulus? Square root of 2 over 2. Any questions? What we did? So that's the modulus, right? What's our next step? Well, we're gonna get step number 2. Oops. We're gonna get theta. In this case, we're gonna get the theta reference angle first. Okay. So what's the reference angle theta for such? This is the formula. Tangent inverse of B over A. Okay. Absolute value, by the way, right? Absolute value. So let's get first, that's the reference angle. So what's that gonna be? Well, negative 1/2 divided by itself will be equal to what? 1. Well, what is the tangent inverse of 1 in radians? Tangent inverse of 1 in radians. In short, what angle in radians will give you a tangent equal to 1? 45 degrees in 45 degrees, but in radians, what's that gonna be, guys? Square root of 2 over 2, that's correct. Okay, however, we want the radian equivalent, right? So what do you do with 45 degrees to make it radians? Pi over 180, right? And what's that gonna be? Pi over 4. Good. But yes, the square root of 2 over 2 is the sine value for that. Okay, anyway, going back in here, so therefore our reference angle is equal to what? Pi over 4. Okay? Yeah. In radians. But yes, you are correct. In degrees, it's 45 degrees as well. Okay? Or recall your 180 pi over 180, right? To convert the degrees into radians. Next, step number 3. Consider the quadrant location, okay, to get what we call, this is called the, it says in there, argument, okay. So the term for theta in here is called the argument theta, okay. The radius is called the modulus. For this one, the argument is called your theta, right? So what quadrant is this? Negative, negative. What quadrant will that be, guys? Third quadrant. So if this is in quadrant number 3, what's the formula to get theta in quadrant 3, guys? If you're given reference angle? Pi plus or minus? Plus. Very good. Pi plus the reference angle. Okay. So what's that gonna be? Theta is equal to what? Pi plus, what's your reference angle? Pi over 4. Okay, and what's that gonna be, guys? Pi plus pi over 4. 5/4 of a pi. Okay, thank you. And step number 4 is to what? Put it on the form. What is the form again? Form is the following. R cis theta. Okay, so what's that form again? What's your R? Square root of 2 over 2. Cis. And what's your theta again? 5/4 pi. Questions? Now, let's verify. How do we plot this? Definitely, we cannot plot complex numbers because we don't have a complex plane. However, we can think of it as what? The xy plane as well, right? So just plotting it in our xy plane, we're going to put the following, right? So the rectangular form, instead of that, we're going to put it as follows. -1/2, comma, -1/2. See that one, guys? Okay. Next one. What is our R again?
Square root of 2 over 2.
Thank you, right? So our modulus is equal to square root of 2 over 2. Okay? Now, what is our angle? We said our angle is how much? 5 pi over 4. So as you may see the theta in here, I'm going to put there the following. 5 pi over 4. Okay. So, did it correspond to what we are assuming it to be? Yes, it does, right? Again, we cannot put in decimals the actual complex plane because this is still x and y axis. But still, you know, treating the y axis as your eye or imaginary axis is a good visual already, all right? Questions? I would say a good approximation. Questions for that? Okay. And the last one, okay? So the last one in here is just giving a try on how to actually multiply and divide, this one in here, okay? Let's try this one in here. Numbers 23 or 24. Choose a number and see what you're gonna do for that, okay? Krish, let's choose a number. 23 or 24? 23. And what do we do with that? Okay, so you multiply z1 times z2, and how do we get it in polar form, okay? This is our formula for such. What did it say? If you have z1 multiplied to z2, what do you do with their modulus in plural form? I think it's moduli, right? Moduli, moduluses, it's moduli, right? Okay. Arguments, right? This is a easier plural form, right, for that. So, just plugging in the following, right? So, Z1 times Z2 is equal to what? Get the product of their modulus, right? So, for number 23, what's the modulus for that? 2 square root of 3. Okay. And what's the modulus for Z2? 2. And then put in here what? Cis, you know what? I'm just going to use red, okay? Now, if you multiply the modulus, the arguments, you're going to add them up. Okay, so what are the modulus in there? It says 116 degrees. So in here, this is in degrees already, okay? And 82 degrees added together. So as simple as that one, okay? So when you're multiplying, what do? You multiply the modulus, you add the angles or arguments. Okay, that will be it. What's this gonna be? 2 times 2? 4. Square root of 3. And then this is what? Cis. And what is this in here? Add them together. How much will that be? 116 plus 82. How many degrees will that be, guys? 198. Okay, so I trust you with that computation. Okay, so once again, as you may notice, your theta or your argument can be in degrees. It can be in radians as well, depending on what is needed. Okay? Questions regarding that? Last one, your quotient. So quotient, what do?
Divide.
Similar to that, but okay, so the quotient in here will be what? 2 square root of 3 over 2. So you divide the modulus instead. And then cis, now what do we do in here? You subtract the angles, all right, or the argument. So in here is what? 116 minus 82 degrees. Okay, so in that case, what now is your Z1 over Z2? So you cancel the 2's. You basically just got what? Square root of 3 cis, and what is this? 116 minus 82. Okay, so you can just use calculators for that. What you get, guys? Okay, 116 minus 82. Oh, calculator.
34.
34 degrees. Thank you. Again, the Moab's rule for complex products and quotients, right? For product, you multiply the r's, you add the angles. For division, you divide as well the r's, but subtract the angles instead. Okay, so please be familiar with this. Next time, we're going to deal with what? Raising it to a power, or even getting the root of polar complex numbers. Okay? Thank you.